Okay, so we're going to be looking at slope and linear equations. Okay, you may remember most of this back from your Algebra 1 days, but when we're talking about slope, we're really talking about the steepness of a line. And there are different ways we can represent slope. We could call it slope. Most of the time when we're talking about an equation, it's represented as m. For instance, the equation you might remember is y equals mx plus b, where m is slope. Most generally, we know that it's rise over run. So when we're talking about a graph, we rise before we run. That's the slope, the steepness of the line. We could also describe it as the change of y over change of x, but what that really means, the change of y really means subtract our y's. So if I give you a set of points, let's say point A and point B, we subtract the y's, we subtract the x, that'd be the change of x, and then the ratio between the two, y's over x, that would give us our slope. Rise over run. Y's being rise, x being run. For instance, if I give you the points A and B here, we could call the first point x1, y1, and then we can call the second point x2, y2. Okay? Well, with that in mind, slope, m, is the change in y over change of x. In other words, I can subtract my y's, divide that by the difference of my x values, and that would give me my slope. Well, let's take y2. y2 is 3, so that's this guy here, minus y1, which is 6, okay? So we'd have 3 minus 6, there we go. So we have our y2 minus our y1. Then we also have x2, 4, minus our x1. Now, this is 4 minus a negative 3, okay? So we got to keep in mind, we can't lose that negative. It's 4 minus a negative 3, which we know turns it into addition. Well, what's 3 minus 6? Negative 3. And then what's 4 plus 3? 7. So the slope of this line would be a negative 3 over 7, okay? So that describes the steepness of the line. Now, in terms of visually looking at it, there are 4 different types of slopes we can have. Positive, negative, 0, and undefined. A good way to think of it is if I have let's say a little stick figure here. If the guy has to walk up the hill going from left to right, so from left to right, that's a positive slope. He's positively walking up the hill. Now, if I have to go down the hill, let's say we have our little guy here again, and from left to right, he's going down the hill, that's negative slope, okay? So from left to right, that'd be negative slope. Now, if the guy's just chilling out, he's really not going anywhere, okay? Maybe he's just hanging out on the open plains of Kansas because it's flat here in Kansas. That guy is 0 slope, okay? So if he's really going nowhere, he's not going up, he's not going down, that's 0 slope, okay? Now, undefined, that would be like, oh my gosh, I'm scared out of my wits right here. I'm falling and I can't do anything about it. Help me, help me. That's undefined slope, okay? So it looks like he's falling straight down. That's the undefined slope, okay? So those are the 4 different types of slopes we can have. Positive, going up the hill. Negative, going down the hill. 0, just kind of chilling out. And undefined, falling, hoping someone would save me for dear life, okay? Now, when we have a 0 and an undefined slope, we're going to come back to that. Notice 0 slope is a horizontal line and undefined slope is a vertical line. But we'll come back to that here in a second. Right here, okay? So this is what I wanted to get to with that, okay? So like we set up here, 0 slope is a horizontal line, and then undefined slope is a vertical line, okay? Where that comes from is the way that the points sit on the graph, okay? So a horizontal line, well, what are all the points on here? What do they all have in common, okay? What does every single point on this line have in common? Well, notice they all have a y value of 3, okay? Every single point on this line has a y value of 3. For instance, this is 1, 3. This is 2, 3. This is 3, 3, and 4, 3, and so on. Okay, so we define a horizontal line to be a y value, and it's equal to whatever the y values are on the line. Okay, for instance, we would call this guy y equals 3. So this horizontal line that has 0 slope, we would call y equals 3 because every point on the line has a y value of 3. Okay, Similarly, with a vertical line, we would call this guy the x value that it's equal to, because notice what these guys have in common, okay? This guy is 4, 0, 4, 1, 4, 2, 4, 3, 4, -1, 4, -2, 4, -3, 4, -4, and so on. What do these guys have in common? Well, they all have an x value of 4. So we would call this guy x equals 4, okay? Because every point has an x value of 4. Notice, this is our undefined slope. This is the guy falling for his life, okay? So when we're dealing with a y equals, that's 0 slope. When we're dealing with x equals, that's undefined slope. And y equals is a horizontal line, and x equals is our undefined straight up and down vertical line, okay? So that's the other type of situations we can run into here, okay? Now, in terms of writing a general equation of a line, there are 3 different types we're going to run into and 3 different types we're going to focus on. There's slope-intercept form, which is y equals mx plus b. That's the form that you're most familiar with. Then there is point-slope form, which is y minus y1 equals m times x minus x1. And then there is standard form, okay? This is typically what equations look like. Ax plus by equals c, where a, b, and c are just some number. For instance, it could be like 2x plus 3y equals 5, okay? That would be an example. Now let's go back to slope-intercept form there first and focus on this guy. Okay, so slope-intercept form, that's y equals mx plus b. The nice thing about the slope-intercept form, it's easy to work with. Oftentimes, word problems are associated with it. There we go. And then this is also the guy that makes it easiest to graph a line with, okay? But we also want to be able to take information. For instance, maybe they give us the slope, maybe they give us a point, maybe they give us 2 points, and we want to be able to write the y equals mx plus b from the information they give us. For instance, let's look at some of these examples they show here. They say, if I tell you the slope is 3 and the y-intercept is -6, can I write the equation of the line? Well, you might say, well, Mr. Pinksterhouse, what is the y-intercept? Okay, well, let's kind of go back to this up here, okay? The y-intercept is wherever we cross the y-axis. For instance, in our example that we were looking at earlier, this was the line y equals 3 because every point on the line has a y value of 3. Well, notice on this graph here, I crossed the y-axis at this point here. What point is that? Well, it's 0, 3. Okay, that would be the y-intercept, okay? So your y-intercept is always going to have an x value of 0. And then similarly, the x-intercept is where we would cross the x-axis. So what would be the x-intercept here be? Well, 4, 0, because I crossed the x-axis at 4, 0. So notice the x-intercept will always have a y value of 0. Okay, and this is going to be helpful for us later on. So this is our y-intercept, 0, 3, and this is our x-intercept, 4, 0. Okay, now let's kind of go back to the example we were working on, and it says we are given the point that, or we're given the slope 3, and we're told that the y-intercept is a -6. Well, the nice thing about that, if we look at the equation y equals mx plus b, m represents slope, and b represents the y-intercept, okay? So m is our slope, b is the y-intercept. So if they give us that, then we already have enough information to write the equation of the line. All I need to do is substitute it in. 3 goes in for my m, and -6 goes in for my b. So my equation would be y equals 3x, and my b would be -6. So if they give us the slope and the y-intercept, that would be the equation of our line. What about if they give us the slope and a point? Well, we can still solve that. We're going to use our y equals mx plus b, but the thing is, since they don't give us the y-intercept, we need to find the y-intercept b so that I can write the equation y equals mx plus b. Okay, the way we're going to do that is we're going to plug in the information we have into our equation. Well, you say, well, where am I going to plug in 4, -1? How does that fit into y equals mx plus b? Well, if they give you the point A, 4, -1, doesn't that mean that 4 represents the x? Yeah, 4 is x, right? What about -1? What would that be? That's y, okay? So we're going to plug it in just like that. In our equation y equals mx plus b, we're going to plug in 5 for m, 4 for our x, and then we're going to plug in -1 for y. What does that leave us to solve for? B, and that's what we want, because if we can find B, just like we had over here, this guy was our y-intercept and this guy was our slope, it was pretty easy to write the equation line, because M is our slope and B is our y-intercept. So if we can find B here, that will make things a lot easier. So plugging that in, we have a -1 for our y, 5 for our slope, and 4 for our x. Well, then it just becomes solving a linear equation. What's 5 times 4? 20, okay? So then I get 20 here. Then to move this to the other side, solving a linear equation, we have to subtract 20 from both sides, correct? So I'm going to subtract 20 from both sides. This guy goes away. Well, what's a -1 minus 20? -21. So what does B equal? -21, right? So now I have enough information. I know M is 5. I know B is a -21. So I can write y equals mx plus b, okay? Y equals 5x minus 21. This would be the equation of my line, okay? Now, the most difficult version they would give us is if we had to find the slope and find B. So let's backtrack here. Here they gave us the slope in B, the y-intercept. Here they gave us the slope and we had to find B. Here we have to find slope and find B. Well, how do I find slope between 2 points? Well, that's the same thing that we did earlier way up here, right? Change in y over change of x. Label your points x1, y1, x2, y2, and find your slope, okay? So that's the process we're going to take in this example here, okay? This is, let's say, my x1, y1, x2, y2, and let's find the slope. Let's plug it into our equation to find slope, which is this guy, change in y over change of x. So if I plug that in, I have my y2, which is 4, minus a -2, minus a -2. Then my change of x, 1 minus 4. So that's what they have here, okay? Now remember, if I minus a negative, what does that make it? Plus. So 4 plus 2 is 6, and 1 minus 4 is -3, okay? Then when I divide that out, I get -2. So, whoops, there we go. This guy right here, this is my m, that's my slope. Well, now I have m, and I have a point, right? Okay, so notice, didn't in the last example they give us slope and a point? What did we do to find B? Well, we plugged that information in to find B, to get B by itself, right? Well, we're going to do the same thing here. Now, it doesn't matter. It really doesn't matter if I pick A to plug in or if I pick in B to plug in. But just because it's A, let's plug in A, okay? So I'm going to use M, my slope of a -2, and I'm going to use point A here. And we're going to plug that in. Now, what does A represent? Well, 4 would be our x, and -2 would be our y. So we're going to plug that in to where they're supposed to go. Okay? So plugging that in, -2 for my m, then we have -2 for our y, and then we have 4 for our x, we get this guy. Okay? Well, what's a -2 times 4? -8. Okay, then I just need to get B by itself, add 8 over, -2 plus 8, 6, right? So B equals 6. So now I have a B and I have my M, I can write my equation. Y equals mx plus B. Well, M is -2, so we get Y equals a -2x, and my B is 6. So this would be my equation, okay? So that's different ways that we can write the equation of a line for slope-intercept form. Now, the other nice thing about having slope-intercept form, if you remember from your Algebra 1 days, is that if we have slope-intercept form, then we can graph slope-intercept form, okay? The y-intercept tells us where we're going to cross the y-axis, and m tells us where to go next, okay? That rise over run, that tells us how to get to the next point. So depending on the fraction that we're given, we're going to go up that many spaces for y, and then we're going to move over that many spaces on our x, okay? For instance, they give us this guy here. Well, notice m, my slope would be 3, and my y-intercept is a -2. Well, the y-intercept tells us where we start on the y-axis, so we would start at a -2, okay? We always start on the y-axis with our y-intercept, okay? So we're starting with a -2. Now, you might say, well, Mr. Pinksterhouse, how do I use 3 to find the next point? Well, treat it like a fraction because we want to represent it as rise over run, okay? 3 can be written as 3 over 1, correct? So that's the fraction I want to use because I need a rise and I also need a run. So this tells me how to get to my next point. I need to rise 3 spaces, 1, 2, 3, and I need to run 1 space to the right. Now, how can I tell the difference between having to go to the right or to the left? Well, if it's positive, we're going to go up and to the right. If it's negative, we're going to go down and to the right. I would just say for most purposes, unless you're good at working backwards, just always go to the right, okay? So positive up, negative down. Okay, and what I'm referring to is our slope. So if we have a positive m, we're going up. If we have a negative m, we're going down. Okay, so in this case, we had a positive slope, so we went up 3 units and we went to the right 1. Okay, let's see if we can get through these next examples fairly quickly. Now, the next example that we look at is point slope form, which is this guy up here. Okay, now really it's just the same thing as our equation for finding slope. They just rearranged it by multiplying this to both sides, and then we would get this guy. Okay, so really it's just the slope formula. They just multiplied the change of x to both sides so that we can get y2 minus y1 by itself. Okay, but what's useful about that is if they give us 2 points or if they give us a slope and a point, we can write the equation of a line. Okay, it doesn't matter if they give us 2 points or if they're giving us the slope and in a point, we can write the equation of a line. Okay, for instance, here they give us that the slope is 3 and the y-intercept is -6. Now, does this equation have b in it at all? No. So they don't have the y-intercept in here at all. However, isn't the y-intercept just the point? Yeah. Now, what is the y-intercept's x value? What is every y-intercept's x value? 0. So isn't that just the point 0, -6? Yeah. Just like these guys over here, if we have a slope and a point, then we can use this. They're just saying the y-intercept, but we know that that's the point 0, -6. Now, with that in mind, we're just going to plug this guy in as our x1, and we're going to plug this guy in as our y1, and then, of course, we plug in 3 for our m. So then plugging those guys in where they're supposed to go, we're going to put in 3 here, we're going to plug in our 0 here, and our -6 here, okay? The reason we can do that is because we know that this guy is our point x and our coordinate x and our coordinate y. And then what that is going to allow us to do is so we can write it in point slope form like this, and then we're going to eventually change it into y equals mx plus b, okay? So we're going to plug it into this, but then we're going to go to this, okay? So let's see how this works. So plugging that in, we get y minus a -6 equals 3 times x minus 0. So after I plug in the information, that's what we get. Well, what's minus a negative change into? A plus. So that's what's happening here. Then applying the distributive property, we get 3x, and what's 3 times 0? 0. So we get 3x minus 0. Okay, so that's where this guy comes from. Now, here's the cool thing, guys. Once we plug in that information, once we apply the distributive property, all it takes is one little move here to get it into y equals mx plus b. If I subtract 6 from both sides, these guys go away and I get y is equal to 3x. What's 0 minus 6? Negative 6. Well, isn't that y equals mx plus b? Yeah. So just by plugging in my point and my m, I'm able to write the equation in slope-intercept form. Okay? Let's see one more example here, and that's the standard form. Ax plus by equals c, where a, b, and c are just real numbers. But the nice thing about ax plus by equals c is that guy allows us to easily find the x and y intercepts. Now, if you remember from what we talked about earlier, the x and y intercepts, let's kind of zoom up there. Okay, let's see if I can find it. There we go. Remember, the y-intercept, the x value is always 0. For the x-intercept, the y value is always 0. Okay, we can use that when we want to find the intercepts. And the nice thing about being able to find the intercepts is that allows us to plot. We could plot the line easy with the standard form. And then also we have that y-intercept there. And then once we find the y-intercept and the slope, then we can go to our y equals mx plus b. Okay, so let's just start by understanding how to find the y-intercept and the x-intercept first. Okay, what you're going to do is you're going to write two different equations. One where you plug in 0 for x and find the y-intercept, and one where you plug in 0 for y and find the x-intercept. Okay, so remember, the x-intercept, y was 0, the y-intercept, x was 0. So that's what they're doing here. They said, let's find the y-intercept and plug in 0 for x. Well, if I plug in 0 for x, I get 2 times 0 plus 3y equals 6. What's 2 times 0? 0. So I get 3y equals 6, right? Well, solving for that, divide by 3, what do we get? Y equals 2. So what's the y-intercept? Well, we said x was 0 and y is 2. So this would be my y-intercept. Okay? Then similarly, to find the x-intercept, we have to let y be 0. Well, plugging that in, we get 3 times 0. And what is 3 times 0? 0, right? So we get 2x equals 6. Well, how do I solve that? Divide by 2 to both sides, and we get x equals 3. So what's my x-intercept? Well, x is 3, and we plugged in a 0 for y. Okay? So that's how we can find the intercepts. Now, the nice thing about that is because now we know this is our b. The y-intercept is always our b. This guy right here is going to help us find the slope. Well, if we have slope and we have b, what can we do? Write y equals mx plus b, okay? Now, what they say here is, notice I can rearrange this so that we can get y by itself. I can subtract ax from both sides to get to here. And then if I divide by b to everything, I get to here. Well, what they're trying to connect here, guys, just to simplify this as best as we can, they're trying to show you that this and this are basically the same thing. It's y equals mx plus b. Well, what piece of this puzzle would be the m? Right there, m. So what they're saying is you can use this as our formula to find m when we're in standard form. Take negative a over b and we'll have our m. For instance, if we look at this guy here, this is a, this is b, and this is c. To find m, we're going to use negative a over b. Well, what's our a over here? 2. We're going to take the negative of it, which would make it negative 2, and b is 3. So we're going to divide by 3. So my slope of this equation is m equals negative 2 over 3. Okay? Now, the nice thing about that is since we can find the slope and since we also know how to find the y-intercept, we could get into our y equals mx plus b. Okay?